Alright, so we are going to work our way through the Ionic Bonding Draw and Name handout because I feel like this will be the biggest overview we can get with all of the ionic bond things. Essentially, I'm going to start off and just work my way through page 2, which means we're going to work our way to question 4 through 12 and get as far as we can in this video. The thing I'd like to point out and that you need to remember, obviously if we're talking ionic bonds, the big thing that you need to think about is the fact that these are between a metal and a non-metal. Okay, so you need to go through, and every time you are doing this, make sure that you understand that there is going to be at least one metal involved, and that's going to be our cation, because it is going to be positively charged because it gives up electrons, and we're going to end up having that non-metal be an anion. And that's going to be negatively charged because it's gaining electrons. So in the process of this whole thing, you should have that in the back of your head. Obviously, if we're talking about ionic bonds, the other major thing that we need to consider every single time is the idea of, is there a transition metal or not? Because the difference between transition metal and not transition metal will dictate how we deal with that specific chemical formula, name, and it'll kind of help you out with the bonding diagram. So let's start out for our very first one. You were given the specific elements magnesium and oxygen. I know that magnesium is the metal. In terms of the oxidation numbers of each, I know I've got Mg happens to be a +2 and oxygen is a -2. Knowing these two things, these happen to balance each other out and cancel and neutralize, which means when we do the whole crisscross thing, they're going to simplify down for a chemical formula of Mg and O, because there would be an invisible 2 here and an invisible 2 here, and those would simplify down to 1 and 1, and again we don't write our 1s. Now in terms of the naming the compound, we got to ask ourselves the big question, is this thing, this metal, a transition metal? Knowing that it's in the alkaline earth metals family, we know it is not. So our name is going to be very simply magnesium oxide. Okay, and we are not using any of the Roman numerals to indicate the oxidation numbers. And then this gets as simple as our singular ionic bond drawing. For magnesium, I have a single Mg, because again I said there was only one, and that has 2 valence electrons. And I have an oxygen over here, which happens to have 1, 2, 3, 4, 5, and 6 valence electrons. So I know that this single electron wants to get transferred here, and this single electron wants to get transferred here. And so my diagram includes 1 magnesium, 1 oxygen, with 2 electrons moving from the magnesium to the oxygen. Working our way to the second problem. We've got cobalt and we've got sulfur. Obviously our metal here is going to end up being cobalt. But this is where we get tricky, asking myself this, I should kind of at this point recognize that this cobalt happens to be a transition metal. So this is going to make our naming a little tricky because we've got to figure out exactly what is going to go in parentheses. I know there's going to be a parentheses, I know there's going to be Roman numerals, but I don't know what number yet. And so to start this off, I know sulfur should have an oxidation number of S-2. Okay? And when I go through and look at the chemical formula here, this 2 is going to transfer up here so that I do have an S-2. The problem is I need to figure out this invisible 1 right here is going to transfer up to the top of the cobalt. So I will end up with a CO +1, okay, because that invisible 1 transferred up. So I end up having CO and +1. So in terms of the actual naming of the compound, because we did a reverse crisscross, and you're taking the invisible 1 that was next to the sulfur, we're going to name this whole thing as cobalt 1, and remember you're putting a Roman numeral 1 in parentheses, sulfide. And in terms of the drawing, again we're going through and we're looking at the chemical formula for the drawing. I know that I need a CO2S. So I'm going to have a singular S singular sulfur, and 2 cobalt atoms. Cobalt and cobalt. And I know right now that sulfide happens to have an oxidation number of 6, so I'm going to put 1, 2, 3, 4, 5, and 6 valence electrons around it. And now many of you are probably thinking, I don't know what cobalt is because it's a transition metal and it's not in any of those families we were told to memorize. Well, the oxidation number for cobalt, or the valence electrons for cobalt, are simply going to be the same as what the oxidation number is. So this cobalt would act like any other +1 ion. So we could think about potassium as +1, or we could talk about sodium as +1, or we could talk about rubidium as +1. In any case, cobalt's going to act the exact same way. So cobalt will have 1 valence electron. And so each of those valence electrons are going to travel from cobalt to sulfur. Now again, the direction of the arrows are very important, and where they're going is very important. You're trying to take this electron and move it so that it is right next to this lonely electron, so that the valence electrons around sulfur will end up being in pairs of 2s, and we end up with 8. This lonely one is going to transfer over to this lonely electron for sulfur, again making a pair. Again, we work our way to the next one, and we are going to start off with silver and bromide. Okay, and that tells us right here, because we've been given the name of the compound, silver 2 bromide. So I know right away that silver happens to have an oxidation number of 2, because that's what the Roman numeral is telling me. So I know I've got Ag plus 2, and I know bromide is automatically going to be Br minus 1. Again, I know that silver was listed first, so it happens to be the metal, and that's because it's also found on the left side of the periodic table. And from here, we should be able to figure out your chemical formula. This 2 is going to go to the bottom of bromine. This 1 is going to go to the bottom of silver, and again, we don't show the 1, so it's going to end up with Ag, Br2. And then from there, we're simply drawing out this whole set with 1 silver and 2 bromides. My silver I'll throw on the left side here, Ag. I'll get a Br and a Br. Now I know for a fact that bromide has 1, 2, 3, 4, 5, 6, and 7 valence electrons. And 1, 2, 3, 4, 5, 6, and 7 valence electrons. My only question is, how many does silver have? Again, oxidation number of 2 tells me that we're going to end up having 2 valence electrons there. And so all I'm going to do is I'm going to take this guy, and he's going to go to 1 bromide, and this electron is going to go to the other bromide. Alright, moving down, we'll work our way to number 7. Alright, so right now I have given you potassium and sulfur. Potassium I know happens to be the metal, and I know potassium happens to have an oxidation number of +1. Sulfur happens to be a -2 and happens to be the nonmetal, and I know that neither one of these, well specifically this isn't even a metal, so that'd be impossible, but this one is not a transition metal, which makes all of our setup easy from here on out. I know my formula. All I'm doing is crisscrossing. The 1 happens to come down here, the 2 comes down here, and I end up with K2S. Again, I ignore the numbers whenever I write out the formula, so I get potassium, potassium sulfide, and my drawing, I'm going to have 2 potassiums, a K and a K, each one with 1 valence electron, because, again, oxidation number of +1, and a sulfur that happens to have 1, 2, 3, 4, 5, 6 valence electrons. So I end up with, we'll go to orange, this potassium gives 1 to sulfur right there, and this potassium is going to give 1 right there. Moving on to NiCl3. So this time I've been giving the formula. I do not know what the name is. I don't know what the oxidation numbers are. I don't have a drawing yet. So let's get kind of crazy. And to figure out our oxidation numbers, I need to uncrisscross this formula. So I know right away that this 3 is going to go up here, and whatever invisible 1 happens to be here is going to go up top here. So I'll end up with a Ni, and then I get this 3, so plus 3, and this invisible 1 is going to go to the top of Cl. Alright, so all of that, Ni plus 3, Cl minus 1 ends up right there. And again, I know nickel happens to be my metal, so I circle that thing. And then from there I need to come up with the actual name. Now, in this set, I know that nickel happens to be a transition metal. So I need to include something in parentheses, a specific Roman numeral. And I know that Roman numeral is going to be 3 because we're dealing with the oxidation number in parentheses. So 1, 2, 3. I know I've got nickel. I know that the backside is going to be chloride. Chloride. And then from there, I need to draw this whole thing out. And this is the first time we've got a 3 involved. So I'm going to have 1 nickel, an Ni, and I'm going to have 3 chlorines. Chlorine, a chlorine, and a chlorine. And each chlorine has 7 valence electrons. You know that for a fact because chlorine happens to be a halogen where every single individual element has 7 valence electrons. And then you're going to ask yourself, how many valence electrons does nickel have? Because that's a transition metal. And this is where we end up having that positive 3. 3 is the oxidation number, so we know that there's going to be 1, 2, 3 valence electrons. Well, my chlorine up here only had 6. I need to add that 7th. So again, I'm going to take one of them and it's going to go there, 1 here, and 1 here. So nickel is going to give one of each of its 3 valence electrons to a different individual chlorine atom. Okay. We've likely got time for 2 more, but in that process I'm probably going to skip one of them. Or skip around. Next set we'll do a quick LiP, number 9. Again, I know lithium happens to be my metal, but I know it's not a transition metal. This is going to be one of your alkali metals, which makes life really easy. So I know lithium is a Li plus 1, phosphorus is a minus 3. So when I do the whole crisscross thing to get this down here and this down here, my formula is going to be Li3P. And I know my name is very simple. There's no numbers, no Roman numerals. Simply lithium phosphide. And so after we name it, we need to draw it because drawing's half the fun. And so I've got a lithium here with 1 valence electron, a lithium with 1 valence electron, and a lithium with 1 valence electron. And I'm sorry that the eyes are coming out absolutely terribly. And I've got a phosphorus that has 1, 2, 3, 4, and a 5th valence electron. If I was a smart man, I would put that 5th valence electron on the backside away from all of the lithiums. Now, in terms of directions, this one has, or your phosphorus has 5 and wants to gain electrons. Your lithiums have 1 and want to get rid of. So I'm going to start off here, and that lithium gets rid of its 1, this lithium gets rid of its 1, and this lithium gets rid of its 1. And I have a complete drawing. And our very, very final one, we'll get through aluminum really, really quick. I may not get to the drawing. But aluminum chloride, I end up, or not the aluminum chloride, let's jump down to an oxidation number here. I end up with, the iron 3 oxide. I'd like to have one transition metal before we're done. What this is telling me real quick is that this guy happens to be the oxidation number 4, iron. So I know I'm going to end up with Fe plus 3. And you should know that oxygen is an O minus 2. I know iron happens to be the metal, and I know when I crisscross these, I'm going to end up with a Fe2O3. And so when I draw this out, I'm going to end up with an Fe and an Fe, and I will end up with 3 oxygens. Each oxygen will have 6 valence electrons. Each iron will have 3 valence electrons. So 1, 2, 3, 1, 2, 3. And in terms of the actual arrows, I'm going to give 2 to this one. I'm going to give 2 to this center one. And I'll give 2 to this bottom one. And I wish I had more time, but I got about 3 seconds left on the recording, so hopefully that helped a little bit.